All right, good afternoon. Okay, so I've been thinking about this. Some of you, if you were in 11th grade, you got an invitation to take a pre-calculus bridge course over summer. And I spoke to most of you about it, but I just want to tell you, the more I think about it, the more I think it's the worst idea in the whole world. So, it just does not make sense to me at all what they're trying to do. The only thing I can say is that it makes the district look good if you take a lot of AP classes. So that's why lots of times they bog you down with AP classes, which I don't believe. I believe you should only take AP classes that you love. So for example, let's say you hate history and they want you to take AP history. I don't believe in that. So I don't believe in that. I think you should only take, because the AP classes are hard. And the whole goal of the AP classes is to pass the AP exam. So there's no point in taking the class if you're not planning on passing the exam. So anyhow, I noticed the list of students who signed up for this bridge class, and I'm happy to say that none of my students have signed up for it. Because what they're trying to do is, if you're in 11th grade, they're trying to get you to take this so-called bridge class. I don't know why I guess they can't call it pre-calculus because it's not. So they're trying to get you to do this during summer to take AP calculus. And a lot of times students are deceived by that, because a lot of times students think, well, if I just try hard, I can do it. And trust me, trying hard is everything in this world. But when you have to have necessary prerequisites, trying hard isn't going to be enough. So for example, let's say I ask you to go up a ladder, but there's like 12 slats missing in the middle. I don't care how hard you try, you're not going to get up the ladder. You see what I'm saying? So if you don't have a good foundation of pre-calculus, there is no way you're going to do AP calculus. So I'm trying to calm down because I am going to tell the district what I think. And it is just absolutely absurd that they're doing this. And the students who are signed up probably have the idea that if they try hard, they'll be okay. And guess what? They're not going to be okay. They're not going to be okay. And I'm not trying to be negative Nancy, but I'm just saying that if they do not cover the pre-calculus curriculum and they start skipping around and omitting things, kids aren't going to be ready for AP calculus. So anyhow, I'm glad to see none of your names are on there. So good job with that. Okay, now on Tuesday, I want to take an exam in the morning on 15.1, 15.2. Okay, so chapter 15 is only 2 sections, and so I want to do that on Tuesday morning at 8. So between now and Monday, if you have any questions about 15.1 or 15.2, make sure you ask me. And today I'm gonna I posted the answers for module 16. We're still talking about logarithms, but they separated into 2 different modules. I posted the answers for module 16, but I haven't posted the assignment yet, just because I wasn't sure how far I'd get through today. So anybody have any questions? Also, they also were talking about an MRWC class, and it's a 4th year math course to prepare students for college math. I'm not going to recommend that one either. So I'm just letting you know that you guys, if you're in 10th grade, you want to take honors pre-cal. Okay, if you're in 11th grade, you want to take honors pre-cal. How's that? Now, if you know for sure, like I had one time my TA, amazing math student, she one day told me, my TA, she goes, I hate math. I'm like, what? She's like, I'm a writer. She was a poet. She liked writing poetry. And she graduated from UCR already, but I'm like, no, you have to take math. And she's like, I'm not doing it. I don't like it. I'm never going to take it. And so I advised her not to take, those math classes. But if for you guys, if there is any inkling that you might go into some type of math related field like engineering, computer science, what else? Architecture, air traffic controller, anything that has to do with math, you have to go along the math route, which is honors algebra 2, honors pre-cal, and calculus. Now, if you're a junior and you know that you are not going into math, then you want to take AP statistics because everybody's required to take, statistics, and so that'll just help you out in college. But everybody else, you're going along the math route. Okay? All right, anybody want to ask me any questions about anything?
For calculus, it's only honors. There's no AP, or is it AP?
It's AP calculus. There's no regular calculus. So I'm going to be honest with you about something, okay? I don't know if I would have taken AP calculus. I mean, I'm not an AP student, plus I was really involved at school. So I was involved in everything. So I did the worst thing possible. And that was skip a year of math. We didn't offer calculus. When I was in school, they didn't even offer calculus. So I didn't even have a choice. But I wish they offered just regular calculus. So, but we don't. We only offer AP calculus. And so there is no regular calculus. So if you decided that you didn't want to take AP calculus, which I don't know, you don't have much of a choice, I would definitely take like AP computer science, because that computer science is, I think it's important class to take because they do programming, and a lot of you are going to be a gamer. You're going to write games, you're going to design games, you're going to go into some type of computer field in that direction, which is going to be very lucrative. It's going to be you're going to make a lot of money. So I think it's important these days to be exposed to the AP computer science course. So I will say this about AP calculus though, you're getting the exposure, which I wish I had had the exposure rather than just going right into calculus at UCR. It was really rough. So at least with AP calculus, you're getting the exposure, which is good. So, and besides, a lot of you, you're going to do a lot better than me anyway, because you guys are smart. I always had to just work really hard at everything. So you may not have as much trouble as I had in calculus. So don't be afraid of it. I'm more afraid that Mr. Johnston's retiring because I do know he's a good AP calculus teacher, and I don't know who's teaching it. And that scares me because it cannot be a patty cake class. It's got to be a class with rigor. So.
Didn't you say that they offered you the position for honors pre-cal? Or that you wanted
it? Not yet. So pray for me. I really do want, normally I don't really care, but I really do want, because of you guys, I really want the honors pre-cal. So I really want it this next year. I think it's important that you have the 2 years of solid foundation. So, okay, any other questions? All right, let's look at some more logarithms then in chapter. You guys, the exam 15.1, 15.2 on Tuesday morning. In this 16.1, we're going to look at properties of logarithms, and I've already given you a couple of them. So let's take a look at 16.1. Okay, guys, this is California Common Core Standard F-LE, so we haven't seen that before, 0.4.1. you do want to do the explore. And what I'm going to do right now, I'm going to give you a whole bunch of properties. Okay, and then we'll go over them. Maybe I should write them over here. Okay, now, A, M, N, B, and C are positive numbers. B cannot be 1, and C cannot be 1. And I just want to make sure I'm clearing this up because I don't know what I was doing the other day, but B for the base of the logarithm, it has to be greater than 0. In one of my classes, I put greater than 1, which is wrong. It should be greater than 0, and B cannot be 1. So in other words, B can be a fraction between 0 and 1, or it could be greater than 1, but it can't be 1. So I'm sorry, I'm not sure what I put in your notes, but that's the definition for B.
Can you move the camera a little bit, please?
Sure. Okay, so you already know this one. It's log base B of 1 equals 0. And you also know this one. Log base B of B to the X, or they're calling it M now, so M equals M. And that right there, that is an inverse property. And here's another one. So if you can look up here for a second, remember what I told you that if the base of the exponent and the base of the logarithm are the same, they cancel out? Well, this is the same. Look, the base of the exponent and the base of the logarithm cancel out. So those are both inverse properties. The base of the exponent and the base of the logarithm cancel out. The base of the exponent and the base of the logarithm cancel out. Okay, there's something called the product property. And the product property says this, that if you have log base B of Mn, a product, you can write it as the sum of two logs. So this would equal log base B of M plus log base B of N, believe it or not. So once again, if you have a log base B of a product, you can write it as a sum of two logs. The quotient property works the same way. If you have the log base B of M divided by N, that equals a difference of logs. So it'd be log base B of M minus log base B of N. This one's a weird one. It's called the power property. And the power property says this, 3 different levels. If you have log base B of M to the N power, believe it or not, you can bring the power in front of the log and multiply to the log. It's a crazy one. So see this power that's an N? You can multiply the log by it and bring it down in front. And then finally, we have the change of base, which I've already gone over with you. And I'll show you the formal definition of it, okay? It's log base C of A, and it's equal to log base 10 of A divided by log base 10 of C. So that's the definition with variables in it. Okay, so what you want to do is have this close by at all times. And if we were at school, you would have to memorize them. So I can't see what you're doing really, you know, as far as what you're holding or looking at. So you guys get to look at these, but if you were at school, I'd make you memorize them. You guys, I have to teach honors pre-cal because do you realize that I've never even seen you in person. Isn't that horrible? Like I have to see you in person. I have to be able to give you a hug, even though we have to social distance, you know, it's like, okay, I'll put my mask on. You know what I mean? It's like, this is all wrong that I never get to see you. And I was thinking I was at Citrus Plaza, you know, in Redlands. And I was thinking, I told one of my friends, I could pass by one of my students right now and possibly not even recognize them. That's sad. So I have to teach honors pre-cal, right?
You just have to now.
I just have to, yeah. All right, check this out. We're going to do a bunch of problems using the properties. All right, here we go. Can you guys see this? What's log base 5 of 1?
Equals 0.
What's log base a half of a half to the 5th?
5.
Yeah, it's this property, right? What's log base 2/3 of y divided by 8? Now, in this problem, they would ask you to expand. And so you want to notice that this is a quotient. So you're going to use the quotient property. So what would you write?
Log base 2/3 y minus log base 2/3 8.
That's right. What about log base 3/4 of 1?
Would it be 0?
If b is not 1, log base anything of 1 is 0. Okay, now in this problem, they would ask you to expand and you want to recognize that that's a product inside a logarithm. So you can write it as the sum of two logs. So what would you write?
Log base 7 of 2 plus log base 7 of x.
Right. And I'm trying to be really careful about the way I'm writing, but you do see the subscripts and then these numbers next to the log and you see the powers, right?
Yeah, Miss Birch, what property was that?
This was the product property. That was this one.
Okay, thank you.
So what I did is we saw it was a product and we changed it to a sum of two logs. Okay, now you're going to have to go backwards too. So if you see something like this, you might have to go backwards. So you notice that the bases are the same, and this is the sum, so you can write it as a product of one log, right? So what would you write? So this is what I'm saying. Look over here. You can go from a product to a sum, but you can also go from a sum to a product, depending on the problem. So what would you write?
Log base 4 of 5 times 3.
And that would be what?
15.
That's correct. What about the log base 9 of 9 squared?
It'd be 2.
That's this property, right? Okay, what if you had this? Log base 6 of x minus log base 6 of t. You recognize that as a difference. And so now we're going to go from a difference to a quotient, which would be what?
Log base 6 of x over t.
Right. So what they might say to you is on a problem like this, they might say condense. On a problem like this, they would say expand. So there's reasons for that. Don't worry about it right now. Okay, I'm going to erase this over here so I can write some more problems. Okay, now this right here is the power property. So how would you use the power property here? What would you write?
Would it be 4 times the log base 2 of 3?
Uh-huh. And they might give you something like that, 7 log base 5/8 of 10. And you would have to write it as a power. You'd have to go backwards. So this would be written as log base 5/8, depending on what they're asking for, 10 to the 7. So this one, you're going to bring the power down. This one, you're bringing the power up. All right. This one, you're looking at it like, what do we do? What do we do? What do we do? This is just, they would ask you to do the change of base. So how would you do the change of base on this?
Would it be log base 10 of 8 over log base 10 of 5?
Close, you gotta mix up. It should be log base 10 of 5 divided by log base 10 of 8. And that's the common mistake. So make sure you don't mix up the order. All right, so you guys want to see how these properties are going to work? So this is just getting you to recognize stuff. So let's see how these properties actually work. All that was to explore, by the way. This is the first objective. It says express each as a single logarithm. Now, in the calculus book, or I'm sorry, in the pre-cal book, it says condense. So expressing it as a single logarithm or condensing is the same thing. And then it also says simplify if possible. And it says, then check the results by converting to exponential form and evaluating. All right, whatever. We'll look at that in a minute. Okay, so here's the first example. It's log base 3 of 27 minus log base 3 of 81. And if they want you to write this as a single logarithm, use the quotient property. So how would you write this as a single log?
Would it be log of 3 and then 81 over 27? Oh, wait.
Close.
27 over 81.
Right, okay, so you're gonna read it log base 3. So log base 3 of 27 divided by 81. Now, do y'all see how you can simplify this? So you can divide the top and the bottom by 9. So divide by 9 would be 3. And divide by 9, hold on, we could divide by 27, right? Yes?
Yeah.
Okay, now pay attention. You think you're done, but we're not. Because remember how we're always trying to make the base, that thing look like the base, make it look like the base, make it look like the base? Well, can't we write this as log base 3 of 3 to the negative 1?
Yeah.
So isn't this log base b of b to the x? So isn't the answer negative 1? Yeah?
Yes.
So if we want to check this, which I never do, but if we want to check this, it would be log base 3 of 1/3 equals negative 1. Well, is that true? Well, this would be, oh, I see what they're doing. Okay. If I took this and I write it in exponential form, wouldn't it be 3 to the negative 1 equals 1/3?
Yes.
So wouldn't that be 1/3 equals 1/3 if you want to check it? So you see what I did, right? I took this step, which was simplified, and I set it equal to negative 1. And then I wrote the logarithm in exponential form. Remember the base to that equals 1/3 in 15(1). Let's do another problem. Okay, here we go. So remember, they want you to write it as a single logarithm. In the pre-cal book, it says condense. So how do you write the sum of logs as a product? By the way, they have to have the same base. If the logs don't have the same base, you can't use the product property. Okay, so how do we use the product property to go backwards?
Would it be log base of 5 to
Of
1/25, 1 over 25 times 625?
Yes. And you can simplify that, right? Because 25 goes into 625, how many times?
It goes in 25 times.
And now are we done? No, because we can make 25 look like a 5. So it'd be log base 5 of 5 squared equals what?
2.
And we're going to check it just because they asked us to check. And it says this, it says check by converting to exponential form. Okay, so what we're going to do is we're going to take log base 5 of 25 and set it equal to 2. And then we're going to write it in exponential form. So exponential form would be 5 squared equals 25. And that is true. Let's try another one. Okay, it's log base 8 of 18 minus log base
Little
8 of 2. Now remember the directions said to write it as a single logarithm. So we do want to use the quotient property. So what would you write?
Log base 8 of 18 over 2?
Right. And what's 18 divided by 2?
9.
So we're looking at this going, hold on a second. I'm never going to make a 9 look like an 8, and I don't care what I do. So on this one, we're going to have to use the change of base. So if they want it, they might leave the answer like that because they said write it as a single logarithm. But they also said in here, I think it said to evaluate. So we would use the change of base, log base 10 of 9 divided by log base 10 of 8, and put the result on the calculator, or put this on the calculator and tell me what you get.
Do you want the answer rounded?
I'll round it. Can you just read the number off to me? I'll round it.
Okay. I got 0.99851.
Okay, can you do it again? Because that's not what I got.
I got 1.056641667.
So the approximate, depending on how they want you to round, would be 1.06 or 57, depending on how they want you to round. So on this one, if you want to check it, you would have log base 8 of 9 is approximately equal to 1.0566. And so if we took 8 to the 1.0566 power, we should get about 9. Is that what you guys got? When you put that to that power, did you get about 9?
Yeah, you get 8.999.
Okay. Now let me just say this. I'm not sure on the exam if they would ask you, but I don't really care about this. But if they ask you on this exam, you're gonna have to do it because it's in the software, so. All right, let's do a word problem. If you guys can open up your books to page 787A. And this is the last objective. It's objective 2. Rewriting a logarithmic model. Okay. There are formulas that involve logarithms. And one formula is actually the loudness of sound, believe it or not. And this formula is L of I is equal to 10 times the log base 10 of I divided by I sub 0. All right, what does all this stuff mean? Okay, this right here, this L of I, that is the loudness of sound in decibels. So this is the loudness of sound in decibels. This I right here is the sound's intensity in watts per meter. And remember we talked about what anything sub-zero is? What this is, it's the intensity of a barely audible sound. So this is the intensity of a barely audible sound or initial sound. Very, very quiet. So I have a note. You can develop logarithmic models from exponential growth or decay functions. Of the form f of t equals 1 plus r to the t, or f of t is equal to, there's actually an a in front, a times 1 minus r to the t. So there should be an a in front, 1 plus r t. By finding the inverse. All right, so let's read this. You can develop logarithmic models from exponential growth or decay models of this form, f of t equals a times the sum, or f of t equals a times the difference, by finding the inverse. We're on page 787. Okay. All right. So, here we go. During a concert, an orchestra plays a piece of music in which its volume increases from one measure to the next. Now, I've actually had 15 years of piano, and I was in the honor band. I played the clarinet. And so I know what a measure is. So a measure, there's so many beats per measure. And so that's what they're talking about, is maybe 4 beats per this measure, 4 beats per this measure, 4 beats per this measure. And that's how music's written. If you ever looked at music, there's these vertical bars. And each of those measures adds up to a certain number. All right, so it says, it increases from one measure to the next, tripling the sound's intensity. Find how many decibels the loudness of the sound increases between 2 measures. So from one measure to the next, we want to know, we want to know how many decibels the loudness of the sound increases between 2 measures. All right, here we go. We're going to use logarithmic models. All right, you ready for this? So the increase in loudness is going to be L of 3I minus L of I. And where I got that from was the reading. So this is the loudness of sound, right? And it says that it increases from one measure, like tripling the sound's intensity.
Can you move the camera a little bit to the second board, please?
Yeah. So what we're going to do is we're going to take that and use this formula to figure out our answer. So this is going to be 10 times log base 10 of I, which is going to be 3I. I really want to use a capital I because little I means imaginary, and I don't want you to think that's imaginary. So let's use capital I. So it's going to be 3I divided by I sub 0 minus 10 times log base 10 of I divided by I sub 0. So all I did was plug that information into the formula. And so I'm going to do a GCF, and I'm going to take out a 10. So I'm going to get log base 10 of 3I divided by I sub 0 minus log base 10 of I divided by I sub 0. So all I did was a GCF, and I took out a 10. Okay, now watch what I'm going to do here. I'm going to, am I going to use the, no, I'm going to use the product. See that? That's a product property, right? I have to be careful here. Okay, I'm going to change the way this is written so you don't get confused. Watch. Doesn't that mean that? There's a reason why I'm doing it. These are equivalent, right? Yes, no?
Yeah.
Yeah.
So watch what I'm going to do. I'm going to use the product property, and I'm going to write this as log base 10 of 3 plus log base 10 of I divided by I sub 0. And what's going to happen is the last two are going to cancel out. So just by me rewriting it, I was able to cancel out all that stuff. So now I just have 10 times log base 10 of 3, and we can put that on the calculator, right? So on the calculator, do log base 10 of 3 and then multiply by 10 and tell me what you get. Crazy problem, huh? So the whole trick was right here. So I rewrote this as a product so that I could use the product property, and these actually canceled out because those are opposites. So the loudness of sound increases by approximately 4.77 decibels. Do you want to see another one? It's like, yeah, sure. It's horrible.
Yeah, please.
All right, this is 787B. And I'll read it. The population of the United States in 2012 was 313.9 million. If the population increases exponentially at an average rate of 1% each year, how long will it take the population to double? And what we're going to do is use an exponential growth model, like I mentioned before, and it looks like this. And what we're going to do is we're going to find the inverse. So do you guys remember how to find the inverse?
Sounds like a no.
What's that? We're going to basically solve for the other variable. Okay, so we're going to divide by p sub 0. And what we're trying to do is we're trying to solve for t. So in order to get him down, we're going to take log base 1 plus r to both sides, because we're getting the base equal to the exponent to get him down from there. So on the right side, it turns out to be t. And on the left side, you have this thing. And you're going to want to use the change of base. So this is going to be, what? Hold on a second. That canceled. Okay, and the change of base would be log base 10 of p divided by p sub 0 divided by log base 10 of 1 plus r. So this right here is change of base.
Move the camera a little bit to the left.
And so if we solve for t, we're going to plug in all the information. So I didn't plug in any numbers. So they said that p sub 0 was 313.9. So basically, I wrote my own formula before I put in these numbers. And they said that the population is 2 times p sub 0, which is 627.8, and the rate was 1%, which is 0.01. So I'm going to plug in that information. So we have log base 10 of p, which is 627.8, divided by p sub 0, which is 313.9. And that's all divided by log base 10 of 1 plus 0.01. And we're going to put this in the calculator. I'd be really careful about how you do it. Like I would find out this number and not round too much, and then find out this number and don't round too much, and then divide. So do me a favor, do log base 10 of that and tell me what you get. And then somebody else do log base 10 of 1.01 and tell me what you get. And then we'll come up with the answer. So it's too messy. Don't put it all in the calculator at once. Just do it in parts.
For log base 10 of 1.01, I got 0.004321, and it keeps going.
Okay, that's what I got. Okay, anybody with the top number? Log base 10 of, and put that in parentheses and tell me what you get.
I got 0.4676105268.
I got 0.3 something.
Oh yeah, sorry, I put in the wrong number. Oops.
That's okay.
I got 0.3010299, and then it just keeps going.
Yeah. All right, so that's what I got. Okay, so now all you have to do is put this divided by that and tell me what you get for t.
I got 69.666, and then it keeps going up.
So depending on how they want you to round, you would say the population of the US will double in Well, about 70 years. I mean, if you want to be more exact, you'd write 69.7 years from 2012 or the year 2082. So if you notice, this problem is pretty complicated. So I did not put numbers in right away. So what I did is I messed with the formula and I solved for t. Then I put the numbers in. So remember with word problems and inverses, remember that you just solve for the other variable and that gives you the inverse. Okay, that
Yeah.
is the lesson. That is the lesson, and we're going to do problems 1 through 17. Like I said, I haven't posted it, but we're going to do 1 through 17. We're going to do the online, and I'm going to provide a practice AB to practice those properties. So if you want to write that, it's page 7. I'll write it down.
Ms. Birch, what was the year? It was 20 what?
2082.
82. Thank you.
Sorry. So, yeah, I already erased the other problem, but yeah. So if you want to look at these problems more in depth, you can actually read what they are in the book. You know how I set it up, if you're confused about the way I set it up. Okay, so we have a little bit of time because class is over at 2:10, so we have about 20 minutes. What I'd like to do is get started on some of these problems. So in the Math Wizard teams in the book, go to page 790 and see if you can do the first few problems. And the first few problems are write the expression as a single logarithm and simplify. So those were the first types of problems that I did. Okay, so we will not report back, and class is over at 2:10 today. So I'll see you in your Math Wizard teams, okay, working on this. All right, I'll see you in there.